Hey, I'm Jose Rangel.
And I'm Jose Reyes.
Tennis players, we often wonder how fast a tennis ball could get. Hit horizontally, so that we can destroy the competition.
To attempt to find the answer, we tried a couple of things. First, we tried hitting the ball hard.
What a start that was.
We then tried hiring a professional to help us out.
Another forehand. Wow. When do you ever see Roger Federer?
But since all of these ideas didn't work, we had to resort to physics to find the answer.
Yes, science!
We first had to find the dimensions of the court. We found out the length of the net is 78 feet, and the height of the net is 3 feet. But we had to convert these feet to meters because the imperial system is whack. This leaves the court to be 23.77 meters, and the net height at 0.914 meters.
The player would have to hit the ball so it goes over the net at 37 inches or 0.940 meters. This is one factor that gets inputted into our equation. We will use the speed formula where speed equals distance divided by time. The distance, which is 11.89 meters. We use 11.89 meters because that's the net's position in the court. This ensures that the ball goes over the net. What we don't have is time. This is where the projectile motion equation comes in handy. Y equals 1/2 gt squared. I'll let Jose explain further and how we got the solution to our problem. There you have it. The ball will reach the speed of 27.14 meters per second, and the result will look like this. And not like this.
Another forehand. Wow. When do you ever see...
So the tennis court is 78 feet, but we will only use half of the court. This is because we're assuming that the ball is traveling at a constant speed, which will eventually stop once it lands on the ground. This ensures that the ball actually has cleared the net and is traveling at the maximum speed it could reach. So there is 39 feet, or 11.887 meters. The net height is at 36 inches. We will add one more inch to make sure that tennis ball does not hit the net. Plugging all variables into the equation, this is what it looks like before solving for speed. We then conclude that speed is 27.4143 meters per second. That is the maximum speed of the tennis ball can reach once it barely clears the net at 0.93 meters. Here is a crude representation of what is happening. The ball clears the net at 0.93 meters and it travels to the left at 27.143 meters per second. While this is happening, the ball is also dropping at 9.81 meters per second because of a gravitational influence. Eventually, the ball should land on the baseline as calculated. Now, I want to let off some strands by talking about the complete theoretical. Here we have half the tennis court, including unknown trajectories. If I happen to gain superpowers, and I can hit the ball with enough force to make the ball go at the speed of light, what trajectories do I need? Because of the quickness of the speed of light, there will be literally no fall in the trajectory of the ball. Like our previous example where the gravitational pull is a factor. The ball could be even represented as a linear equation because of the straight path it will take. So therefore we could calculate the trajectories using the law of cosines and the law of sines. We have the net, but it doesn't matter how tall it is. What matters is the height in which contact is made with my racket, and the position in which it is hit. So I'm assuming that the ball would be hit at 6 feet and 4 inches, or 3.6 inches. Being converted to meters, the height in which the ball is hit is 1.93 meters. The ball would be hit right over the net, which means the distance from the bottom of the net to the baseline is 11.887 meters. What we don't know is the angle that the ball would travel, nor the distance it would travel from the top to the baseline. First, I decided to find the distance it would travel from the point of contact to the ground at the baseline. So we use the law of cosines because we lack the sufficient measurements. A squared equals b squared plus c squared minus bc cosine A is used. Once we fill in the variables and do the math, it will eventually lead to the answer. We found out that 12.042 meters is the distance it will travel. But most importantly, we need to find the angle, and since we gained the sufficient variables, we could use the law of sines. The process is shown here, and we see that b equals 80.797 degrees. This means that this is the angle that it has to be so that one can hit the ball at the speed of light and hit the baseline. Pretty fascinating stuff, but how hot would it get if I do this? A lot of energy had just been released once I hit the tennis ball hard enough to reach the speed of light. And how hot would this area become because of this? First, I have to find the kinetic energy. It is found by this equation: kinetic energy equals mass times velocity squared. The mass of the tennis ball is 0.0585 kilograms. The velocity will be the speed of light. Being plugged into the equation, we get 163 trillion joules. We can convert joules to Celsius. 1 joule is roughly equal to 1,899 degrees Celsius. So that means that there is 80 million degrees Celsius. To compare it to the sun, we convert that amount to Kelvin. We add 273 degrees to convert it to Kelvin. Not a whole lot of difference, but still. That's how much Kelvin is generated. In comparison, the sun is only 5,778 Kelvin at the surface. This means that the heat produced at the tennis court is 14,000 times hotter than at the surface of the sun. In other words, we all be dead. Have a nice day.